Here you have a problem here. Um, the problem states the hats of 5 person are identical and they get mixed up. Each person picks a hat at random. What is the probability that none of them will get their own hat? So it's a dearrangement problem. So first, probability none of 5 people get their own hat. So what is the total ways to distribute a hat? It's 5 factorial, right? So it's okay. Hold on. Why is my pencil not working? Just give me a moment.
Okay, yeah, now it's working. Excuse me. So total ways to distribute a hat is 5 factorial, so there are 120 ways. So what are the number of derangements? So none get their own hat. Okay, so it follows a series. I know it's a different problem. So that formula is n factorial, 1 over 0 factorial minus 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial. This is a dearrangement problem. Okay, so your final response is going to be, because this, okay, let me write it first. So it's 5 factorial, 5 inverse factorial, 120. 120 because there are 120 ways. 1 minus 1 plus 1 over 2 plus 1 over 6. Oh, okay, sorry. You know what? This goes alternatively. So this becomes minus, again, so minus, this becomes minus as well. Plus 1 over 24 minus 1 over 20, okay? So total probability once you solve gets 44 over 120. So the important thing is to remember this formula for dearrangement, okay? Next question is, Shelley forgot her mobile password and called customer care for help to unlock her phone. The customer care told her that with the assistance of a machine learning techniques, they have developed 50 passwords to unlock her phone, out of which only 1 is correct. Can we describe the outcomes in sample space as uniform distribution? Okay. Question asked, can 50 possible passwords, only 1 is correct, can be described as a uniform distribution? So answer here is yes. Okay, so the answer here is yes. The reason, if each password is equally likely to be correct, then it's uniform distribution. And we know 50 random passwords are generated by machine learning. Okay, so these 50 passwords follow a uniform distribution pattern, so that's why it's yes. Find the probability of getting numbered card. Some number should be mentioned on that card when one card is drawn at random from a pack of 52 cards. So probability of getting a numbered card from a deck of 52 cards. So numbered cards are between 2 to 10, okay? Ace is not a numbered card. Ace is not a numbered card, okay? Just remember that. So each suit, clubs, diamonds, hearts, spades has 9 numbered cards between 2 to 10. So total numbered cards are 9 times 4 because there are clubs, there is spades, there is hearts, and then there is diamonds. So there are 4. And there are 9 ways between 2 to 10. Okay, so there are 36 numbered cards. Total cards are 52. So your probability is going to be 36 over 52, which is, again, 9 over 13. So correct answer is 9 over 13. This is a very simple problem. If you know, in my opinion, you should learn the different cards and what those cards denote in playing card game.